So let's look at an application of slope. So here's a little word problem we have. If a highway has a 6% grade, determine the slope of the highway. Well, 6% grade. Grade kind of implies how the steepness of the highway goes. You may have seen those signs if you ever are out much on the highway. But a 6% grade kind of implies 6% slope. So grade is a synonym for slope. So, but slope, remember, is more of this rise over run concept. But remember, a percent can be expressed as a fraction. So 6% is equivalent to 6 out of 100. So if it has a 6% grade, what that could mean is for every 6 feet it rises, there's a run of 100 feet. So if I sketch that out, I can kind of maybe go by threes here. If I want to go by 100, I probably want to maybe count by 25s or something. So these are in feet. This is in feet. So what I can do is for every 6 feet it rises, there's a run of 100 feet. So starting at the origin, just as a starting spot, you can start it anywhere, but keep it simple for me. Start here. If it rises up 60, it's got to run 100. So from this spot here, rising up 60, it runs 100. That would be the sketch of the graph. So the highway has kind of this look to it. That's its steepness there. Again, since I really kind of distorted the scales, it's probably not that steep. Notice how I went 50 this way and I counted by threes this way. It's probably going to be a lot less steep if I kind of adjust those scales, but you can kind of get an idea. It's definitely running a lot more than it's climbing. So it's not really too steep of a grade. So a 6% grade, you could probably run that fairly well in your car. Even the smallest cars could probably manage that fairly easy. So determining the slope, what we pick up on is all I got to do basically is just change this to 6 over 100, and that would be the slope. Now if I want to put that in lowest terms, I've got even numbers here, so I can divide by 2, make that 3 out of 50. So I could reduce that slope down to 3 out of 50. But either one of those will be acceptable answers, because the slope is simply a rise over run. I drew the graph just to kind of give you more of a visual, but I really wouldn't even need the graph. The 6%, all it has to be expressed as a fraction, and once you express as a fraction, that is now slope language, because you have this numerator-denominator concept, the rise over the run. And remember, the numerator is how far it rises, and the denominator is how far it runs. And that's how you can kind of visualize that on your graph. The rise of 6 and the run of 100. Okay? I think I got one more application to play with, so stay tuned.